still tape it?
No.
I can't have C.
It's on.
Okay, thanks. Yeah, we're going to cover the surface water treatment rule. And again, this is something that was put in place to enhance protection against microbial contaminants. Of course, in surface water, you probably will have a lot of more of those microbial contaminants as opposed to groundwater. And it's applicable to your subpart H system. They denote it like this, but all that we're talking about are those systems such as your surface water or groundwater under the influence of surface water. Those are the two type systems we're talking about when we talk about subpart H. And I noticed that you were one of the few that had written that down correctly the other day. So, very good.
Yeah, it's only feel like I can remember it. Yeah, it seems weird when you read it, but I think if we first do that section in the guidance, that part is the surface water.
Yeah, well, excellent.
Yeah, and that does read funny, like, huh?
All right, surface water treatment rule did establish the maximum contaminant level goal for a lot of these microbial contaminants. And again, because whenever they are present, there is a risk. And if there is a risk, the goal will always be 0. So the maximum contaminant level goal for the microbial contaminants is 0. And that's for Legionella, Giardia, Lamblia. Again, they're looking at a reduction of a 3 log or 99.9% reduction of that, as well as that 4 log reduction of your viruses. Again, any exposure presents some level of health risk, so the detectable disinfectant residual must be maintained throughout the entire distribution system under this particular rule. 1989 surface water treatment rule did not specifically take into consideration or control the cryptosporidium, but it was just the other microbial contaminants there. We keep the detectable disinfectant or the residual chlorine or whatever disinfectant you use in order to, again, kind of combat these particular items here that are susceptible to disinfection. Components implemented to improve and enhance the reduction of public health associated with cryptosporidium is another part that is now included in the surface water treatment rule. We have the interim enhanced surface water treatment rule that looked at lowering stability standards for your largest system. And the reason they looked at lowering the turbidity, because a lot of times turbidity can be a host or harbor these pathogenic organisms. They kind of shield them. And so by lowering that, of course, you're increasing your chances of getting rid of those microbial contaminants and cryptosporidium. Your long-term 1 enhanced surface water treatment rule extended the requirement of the interim to those medium and smaller size systems. So whereas the first one, we're looking at the largest system as far as this requirement, with that long-term 1, it took into consideration those systems serving fewer than 10,000. And then we have the long-term 2 enhanced surface water treatment rule, where we see additional language in there for the cryptosporidium at your surface water, as well as your GUI system, groundwater under the direct influence. In other words, what they're saying at this point, you need to significantly decrease the levels that are in your source water. All right, the filter backwash recycling rule, we saw what that entailed, pathogen reduction by properly maintaining and managing your backwash water and waste streams at your water treatment plant. Stage 1 disinfection byproduct rule. This reduced the exposure of the disinfection byproducts such as the triomethanes, aliacidic acids. And stage 2, further reduction of those disinfectant byproducts throughout the distribution system. So all of this is a part. All subpart H systems are required to filter their water unless there's something else that's in place, more stringent source of treatment is implemented. The filtration can include, if you have any unfiltered sources, what they say is that you gotta go back to the 1989 source water sites, I can't say that word, specific requirements, and go by there. You must include cryptosporidium in your source watershed control program. Do you all have any unfiltered sources? No. Okay. And this just is a continuation of those sources, that they must meet the stage 1. They are subject to disinfection profiling and benchmarking, as well as the sanitary surveys. And they are required to provide 2 sources of disinfection to meet the total inactivation of Cryptosporidium giardia or those viruses. So that was your unfiltered source. You don't have that. Let's move on to the filtered sources. Okay. Now, number of samples determined by the population. If you have less than 500, you're looking at 1 sample per week. Under the 3,300, 501, 2 samples per week. You have to sample on separate days.
Now, what sampling is this?
Huh?
What test are range for the sample?
This right here,
Yeah.
this is looking at all of those in order, like recordings and things like that, in order to ensure that you're meeting those disinfectant byproducts. Okay. And I think that's on, what page is that?
Probably like the continuous monitors.
Yeah, that's what I was wondering. They were monitoring routinely every day.
Chlorine, turbidity. Now with the turbidity, it's going to be a little more, because we're looking at with turbidity filter sources, you're going to run those turbidity readings every 15 minutes on some sources, and some of your groundwater sources you're looking at every 4 hours. So
The
we'll
chlorine.
get to that.
Small surface water systems.
Okay,
All of our surface water systems
are the larger ones.
But the TTHMs, the H85s, aren't water.
Yeah, that was not that sampling on there. Now, the only time that you would increase that if you are in some situation where they are exceeding the
Yeah, I think with the stuff they take daily, your chlorine, your pH,
Right.
stuff. It's stuff they are doing on a daily basis. Not the water work report. Huh?
Very
Yeah,
similar to
similar
those.
turbidity on it. It's stuff they're doing on a daily basis. So our systems are so huge that they have to do it on a daily basis.
All right, for the filtered sources, and this is where you come in, the limits are determined by the type of filters in use. Now, what this is saying is that you want to make sure that your filters are able to meet what the requirements are. And whether you're doing combined or looking at individual filters, 9 times out of 10, that's going to be equal to or less than the 0.3 NTUs in at least 95% of your monthly sample. We talked about conventional or direct filtration systems, and remember with the conventional, you're talking about the one with the sedimentation included in the process. Direct filtration is without that sedimentation, where you go directly from adding the chemicals and mixing, and then straight to filtration itself. For combined filter effluent, you're looking at equal to or less than 0.3 and 95% of your monthly sample. And here with the combined filter effluent, you're looking at taking that reading every 4 hours, and that's as the plant is operating. It should not and cannot exceed 1 NTU at any time. And again, system less than 500, your sampling can be reduced to one per day, but that's with the blessing of the primacy agency giving you that okay to make that reduction. For individual filters, effluent turbidity, these are monitored with a continuous approved method, and your turbidity meters must be calibrated according to the manufacturer's recommendation. Here, we're looking at turbidity readings every 15 minutes. Not the 4 hours, but every 15 minutes for your individual filters. Now, if your meter failed, then they will allow you to go to the every 4 hours. However, you have 5 days to get that meter back online. 5 days to get it back online. The information you want to make sure that you're getting to the agency whenever you have levels above 1 NTU and 2 consecutive measurements, 15 minutes apart, that has to be reported. You're going to let them know the filter number, turbidity measurement, the date of the exceedance, and you may be asked to create a profile within 7 days for the abnormal performance. And the reason I say you may be, it depends on what size system. Larger systems are required to do this, smaller systems at the discretion of the state agency. If you have diatomaceous earth or sand filters, you're doing turbidity measurements as your combined filter effluent. Again, that, remember, was every 4 hours the plant is operating, and it has to be less than 1 NTU and 95% of your readings taken each month. No readings in this case should exceed the 5 NTUs. Now, less than 500, again, the state agency has the authority to reduce your monitoring to 1 per day as opposed to the every 4 hours. So, as far as disinfection profiling and benchmarking, any significant changes, you got to work with the primacy agency to determine whether or not you need to do this. They will help you develop the disinfection profile and calculate the disinfection benchmark there. Some of the changes are types of changes under this rule we're talking about if you want to change your disinfection or change in your application points where you're administering it, or the reduction or addition of your application points. Cryptosporidium, again, the maximum contaminant level goal is 0, and you need to make sure that you are proving that you are meeting that 2-log removal for systems under the surface water treatment rule. Systems using conventional or direct filtration, they're holding you to the less than or equal to the 0.3 NTUs, because remember, you're looking at turbidity reduction. And with your diatomaceous earth filtration, a 2-log removal and less than 1 NTUs and 95% of the sample taken. With the interim enhanced surface water treatment rule, again, these are the requirements, and remember, one of the stipulation was that you maintain a residual disinfectant throughout the distribution system. So in addition to the reduction of the Giardia lamblia and viruses, 3-log, 4-log respectively, you're looking at least a 0.2 milligrams per liter entering that distribution system. And your manual do have turbidity standards for your systems that will serve more than 10,000. Usually it's a little more strict there. Yes, ma'am.
My entertainment, please tell me, if a surface water system collects a total coliform sample and gets a chlorine residual less than 0.3 or 0.2 out in the distribution system, what should they do then?
What should they do once they've collected? What we tell people normally to do, first of all, before we pull that coliform sample, we're going to check the chlorine. If the chlorine is beneath that 0.2, 0.3, we don't continue the process of collection, but we flush, make sure you got well chlorinated water coming into that area, make whatever adjustments that need to be adjusted, and then go back and pull your sample. After the fact, you got the positive, you're going to go ahead again and start implementing. Again, you're going to do your repeats, of course, but in the meantime, you want to make sure you have chlorinated water in that area and to determine why it was so low.
So as a state agency, they collected their sample, they reported their chlorine less than 0.08 or something.
Yeah.
And so I guess that kicks in that V equation and heterotrophic plate count and that sort of thing.
So you all do that.
Well, that was part of the original rule, right? The surface water treatment rule, and we've never deleted it out of our regulations.
We don't do that. And we do have the band classification, but we don't go into the heterotrophic plate count at all. So that's something that part of
So-
your investigation.
You require them to have .2 coming into the distribution system, and then you require them to have a chlorine residual throughout the distribution system.
Absolutely.
And what I tell my water systems with the kits and the technology that we have today, I'm saying anything less than a 0.04 is equivalent to zero. You know what I'm saying?
Absolutely.
I'm writing it down.
Now, keep in mind, this right here is just the minimum, and so although we say .2 is not what we are really, that's not our target point, by no means. Because if you look in our rules and regs, and the farthest reach of the distribution system, we should be achieving the .2.
That's where our .3 comes in.
That's where your point.
We should be probably issuing violation letters if we get results saying they're less than .3.
But I guess part of the thing is, your guys are actually pulling the sample, so they're going to pull the sample regardless of whether or not it's a .3 or a .02. You're going to continue the process because they're out there pulling the sample.
Right, and we try to be fair about it, and we'll run the water at least 5 minutes, sometimes 10, to try to get a chlorine residual in if we get nothing. But, we don't really have the control to run the system with the flush or to increase it as a plan or anything like that.
And that's part of the beauty with the operator doing it. He has that option to make sure that's happening, to reduce the possibility of it.
Well, the problem is a lot of these systems, like our big surface water plants, when they're pulling 100 samples a month, people that are pulling the samples aren't always the actual operators.
Right.
You gotta come back and say, hey, I only got these numbers. But then most of the people that are pulling the samples are just hired just to pull the samples.
Full sample.
So that's what the problem. Some for smaller systems, then yeah, they're kind of do double duty, but a lot of our large systems that do bulk sampling, the samplers just have nothing to do with operating the system.
So, different setup scenario. Okay, with your surface water, groundwater under the influence serving 10,000 or less, turbidity levels implemented during the interim, and it also again requires disinfection profiling and benchmarking.
Disinfection profiling and benchmarking is basically for the subpart H systems, rather
Right.
than messed up on that.
Okay. This is for the long-term one enhanced surface water treatment rule. And again, for those subpart H, as you said, serving less than 10,000. 2 log removal of cryptosporidium in your finished water reservoirs must be covered. Unfiltered water system must comply with the watershed control requirements. And again, you're looking at and adding cryptosporidium as an organism or pathogen of concern there. Okay, now with the long-term 2, now you went into that phase where you had to do the gathering of the information, so to speak, monitoring for cryptosporidium, gathering that information for 2 years. Based on the results of your cryptosporidium for 2 years, then they classified you in a certain bin. And based on what bin you were classified in, that now set up your frequency for future monitoring and so forth. Now, with your smaller systems, they were allowed to use E. coli instead of cryptosporidium. Systems then were put into those 4 bins, as we said, after the 24-month was completed. And this sort of gives you a timeline for compliance for that. So for your smaller systems, and you all of your systems are greater than 10,000 surface water, okay. So that would have, again, you're looking at either January 10 for the cryptosporidium as far as when you start to submit your sample schedule and description. You began your first round of source water monitoring by April 2/10. Submit your DIN classification filter unfiltered by September 2/12, and then comply with the long-term 2 surface water treatment rule October 14, and then you're going to begin your second round by April 2019. So once you completed the study, again, then 1, 2, 3, if you had less than 0.075 old cysts, you were classified in BN1. The more old cysts that were found put you in a higher bin. So based on that, if you had conventional filtration treatment, including softening, and if you were in BN1, but as you can see, BN1, no additional treatment was necessary, regardless of whether or not you did just a conventional direct or sand filter or another type of treatment technique filtration. With BN1, because your levels of cryptosporidium was so low, no additional treatment was necessary. However, when you get up to like BN4, and remember, with BN4 you had greater than 3 old cysts. BN4, now if you were dealing with, or if you were implementing the conventional filtration, that's what you had to provide an additional treatment where you met the 2-log treatment. For direct, you need to do that 3-log. For your sand filters or your diatomaceous earth, 2.5 log there. And here, this is where the state has some say into how you're going to remove, what you're going to remove. They gave that leeway back to the state there. And
That would be like
it's the
membranes.
5.5. Right, your various types of membranes. Your nanomembrane, reverse osmosis, ultrafiltration. So where did you all fall?
We have one water system that fell in bin 2,
Okay.
and they were conventional
Conventional?
filtration. And they opted to get their 1 log credit. They got a half a log by doing source water protection upstream,
Okay.
and they have given a lot of money to fencing around, cattle farms
Right,
and
right.
mushroom operations, and repairing, buffer zones and things like that. Dog pickup,
Okay.
education, and the other half log, they went to individual filter turbidities at point, was it 125?
0.15?
0.15, yes,
Okay.
0.15 at their individual filters. So
Okay.
they actually didn't change any treatment.
But because of the source water protection,
So
more or
they-
less.
And I think Delaware's like #1 in this sort of scenario of having a source water protection program approved for.
Right, for the credits.
Credits.
Okay.
And they had tried different treatment options in the plant, and
Did it work?
the things that they tried adding coagulants earlier on and different chemicals, and nothing seemed to work, so that's why they took this option.
And now, since they've taken the option.
So far, so good. So
So
far,
far,
so
so
good. They've been in compliance with the individual filter
Filters.
turbidities.
And that's the key, that's always our goal, is you gotta continue that monitoring process to make sure what you've implemented is actually working. Excellent.
We're participating in the AWAT program.
All right, additional treatment option is in the microbial toolbox, and as you just said, you talked about one of the options you gave your guys was the source water protection management option. Of course, it's always out there and available, especially if it's going to make a difference. additional options would be filtration, treatment performance options, or additional filtration or inactivation. So all of those are things to explore and to determine what's applicable for your type of system that you have in place. And of course, with everybody, they want to do as much as they can to meet the requirements without spending a whole lot of money on your system. All right, with the stage 1 disinfection byproduct rule, again, we're trying to minimize and reduce those disinfectant byproducts that are formed when we have an excessive amount of chlorine and all this naturally occurring organic matter, leaves, algae, and stuff like that, and produce a byproduct which can be a cancer risk and has been shown to be a cancer carcinogen to your laboratory animals. So we're looking at total trihalomethanes, maximum contaminant level of a 0.08. We're pulling 1 sample per quarter for systems 500 to 10,000, 1 sample per year for systems less than 500. Now, with the systems that are pulling the 1 sample per year, the stipulation is they want it taken during the warmest month of the year, not during the coldest. And if you're exceeding that MCL, now that has just been increased to 1 per quarter. Compliance there based on a running average. For your groundwater systems, sampling frequency is 1 per year. And again, it increased to 1 per quarter if you've exceeded the MCL. Acetic acid, the limit is 0.06. For bromate for plants using ozone, do any of your plants utilize ozone?
We got one.
Oh, you do?
We got groundwater plant that does ozone.
Oh, cool. Is it as the final disinfection?
No, they had chlorine for the distribution system.
Okay, to make sure because there is no residual with
I think they
ozone.
use ozone as help with coagulation, help with the filter or something, I think.
Well, it was the city of Dover, and,
It is the city.
we were 40,000 people here. They did not want to chlorinate, and they were trying to avoid chlorination.
Okay.
And they built this plant with ozone to avoid
Expensive.
chlorination. And it actually was set up, with a lime and chlorines, and I believe it was built probably 5, 6, 7 years before it was ever put into service. So by the time they worked all the bugs out and got it operating, they kept the ozone and they converted the little chlorines to just regular chlorine. And they had they had an E. coli in the distribution system from a elevated storage tank. Got in.
Okay.
And so we mandated that they chlorinate. And so the plant that they built to avoid chlorination,
You're still chlorinating.
they're chlorinating everywhere now.
Okay. So for those, we are looking at the bromate of 0.01, and again, that is sampled monthly. Chlorite, chlorine dioxide is a form of disinfection that will produce the chloride chlorates, which are concerned because there are health risks associated with them. So maximum contaminant level 1, goal is 0.08. So here we see a maximum as opposed to a minimum. But when you look at chlorine dioxide versus chlorine, you're getting probably a stronger biocide agent, stronger oxidizer with the chlorine dioxide as opposed to chlorine. The other beauty is that it also takes care of the RDA cryptosporidium. But the chlorides and chlorates are something you have to make sure that you are monitoring too. So we're doing daily sampling at the entrance to the distribution system to make sure we're well below that maximum contaminant level, monthly samples within the distribution system, And if your MCL is exceeded, you got 24 hours to get that back there to the sample.
Is chloride known by anything else?
What was the question?
Chloride, is it known by anything else?
Is it known by anything else?
Like chloride or?
All right, it's two different things.
I had a vegetable plant, processing plant, called me yesterday about Hanover Foods was asking about using chlorine dioxide. And basically, they don't, not so much for the drinking water system, but to wash the vegetables.
Okay.
The vegetables in their production line. So I told the compliance was rather complicated. Maybe they will decide against it.
Was it very, very weak chlorine dioxide that they were looking at using?
I think they were, gonna put it in with whatever requirements were for drinking water, but to just run it basically for production,
Department of Ag went on
Yeah.
Yeah.
that.
All right, free chlorine, we have an MDRL of 4 milligram per liter, and that's typical of EPA language there, and that's with the running average, so it might spike up above the 4, but with the running average, you're good. And it's going, yours spike up quite a lot?
We found that when you have about 20 or 30 milligram per liter of chlorine in drinking water, you really can't detect it with your nose anymore.
Oh, absolutely. I wholeheartedly agree. That's why we have approved methods, meters, right? Yeah. And these are pulled at the same locations and frequency as your coliform sample. Same with chloramines, as with the free, you have the MRDL of 4 and pulled at the same location and frequency. Now your DPV precursors, for total organic carbon sample set, these are calculated, and again, once per month, and you want to make sure you're including alkalinity, and compliance is based on the ratio as opposed to actual removal data. Some alternative methods for compliance would be your step 2 jar test or source water monitoring and kind of handling the TLC where it's less than 2 milligrams per liter as a running average. Raw water specific UV absorption less than 2, or your finished water, again, less than 2. Those would be the alternative for compliance. All right, for your community water system and non-transient, non-community with primary or residual disinfectant other than UV, you're going to have to do the evaluation is the bottom line here. You want to identify what those high-risk areas are, looking for the disinfectant byproduct because it's a possibility for it to be there, especially if you have older lines and a lot of buildup in those lines, and now you have chlorine. There is a possibility to have these disinfection byproducts also. So MCL for TTHMs and halicic acids are calculated at each monitoring location. And again, because we have identified, we did the evaluation, we know the high-risk area, now we're looking at a localized or locational running average as opposed to the entire system. Exceedance of an operational evaluation level must review the practices, operational practice, submit that report to the state, identifying what actions that they can take to mitigate the further or the reduction of these byproducts.
We've got 2.
We have 2 of them? So what are they going to do? Oh, okay, we just got them in.
Yeah, I got one for the city of Wilmington and that Bethany submitted one, even though their smaller system, they really weren't required to submit it yet, but they would have triggered it if they, you know, it would have been.
So it's just right special,
Or they are.
I actually saw some of the clip on the news about them and their name that we have. So in a nutshell, that's the surface water treatment